Hey guys, welcome back again in our Engineering Mathematics 3 lecture series. Already we have started a lecture series based on the M3 and important question from SPPU exam. So in our today's video, we are going to learn some of the example based on the complementary function with some of the example based on synthetic division also. So mostly I focus here the important question for SPPU exam. So if you are interested to see similar videos, go and check in my playlist. You will get the all entire videos in my channel. Okay, so let's get started our today's lecture with the example on complementary function. See guys, you will get these examples for 3 or 4 marks in your exam. It's not that difficult, it's very much easier. Okay, so you must need to understand how can we apply solution for differential equation, and just need to find out the roots for a simple equation that will give you a good marks. Okay, so let's get started here with our first example. Find a complementary function. Okay, so you will get the question in your exam, find complementary function, and you will get the equation as a d raised to 4 minus a raised to 4 which is equal to 0, or instead of that you will get the d raised to 4th of a d raised to 4th of y by dx raised to 4 plus minus, sorry, it is minus given here. Okay, so minus a raised to 4 which is equal to 0. So you will get the linear differential equation as d raised to 4y minus dx raised to 4 minus a raised to 4, and dependent and independent variable as x and y here. Okay, so don't get confused, both of these are having similar meaning. So you have to convert this one into the auxiliary equation. Okay, this one is linear differential equation and this one is the auxiliary equation for our linear differential equation. Okay, let's go for finding the roots for our differential equation. Now see that till now we learn how to find the roots for quadratic auxiliary equation or cubic auxiliary equation using synthetic division. Now this one is a 4th power. So it's my hint here to you all, whenever you will get the 4th power for our auxiliary equation, so directly convert into the square. Okay, so d raised to 4 can be written as d to the power 2. Now see here carefully, we write d to the power 2 to the power 2. Okay, when power to the power we write d to the power 4 here. Okay, minus a to the power 2 to the power 2. Okay, which is equal to 0. See that what I have done, d raised to 4 written as d raised to 2 as a to the power 2. Okay, when we have power to the power, then we multiply them. Okay, a to the power 2. Okay, so this one is the actual auxiliary equation. Now we want the roots. Okay, we want the root, that means apply directly the standard result that we know which one of the famous result, a square minus b square, which is a minus b into a plus b. Okay, this one is the a minus b into a plus b as a square minus b square, a square minus b square expansion. Okay, so see that what is the value for a value for a is a d square directly. Okay, value of a is a d square and that square it is here. Okay, and value of a b which is a square to the power 2. Okay, so replace d raised to 2 minus a raised to 2. Okay, d raised to 2 minus a raised to 2 and minus, sorry, we have multiplication. Okay, d raised to minus a raised to 2 and d raised to 2 plus a raised to 2. Okay, which is equal to 0. This is the expansion I written here. Don't get confused, just I replace the value d square as a a here and a square as a b here. Okay, and then I kept that power as it is. So now see that we got this 2 bracket which multiplication is 0. Okay, now see that whenever we have two numbers, their multiplication goes to 0. Okay, multiplication of a two number, it goes to 0. That means obviously one of the number need to be a 0. Okay, one of the number need to be a 0, then only it is possible their multiplication is 0. Okay, and we actually don't know this one is 0 or this one is 0. Okay, so we write this one as d square minus a square which is equal to 0, or d square plus a square which is equal to 0. Okay, that means this one is 0 or this one is 0. Maybe both of these are 0 or one of them need to be a 0. Okay, yes, so we can write d square minus a square which is equal to 0 and d square plus a square which is equal to 0. So we can see here we got the root as d square minus a square is equal to 0. So we write d square minus a square which is a d minus a into d plus a which is equal to 0. I'm expanding this one. Okay, d which is equal to minus a and d which is equal to plus a which is equal to 0. Okay, that means a square minus b square is a minus b into a plus b. Now see that how can we write the solution? Again see that multiplication of 2 bracket is 0. That means d minus a need to be 0 or d plus a need to be a 0. Okay, so here we can see we got the one more root here, d which is equal to a or d which is equal to minus a. Okay, so these are the two different roots from here. Okay, now see that again d square plus a square which is equal to 0. Remaining part it is here. Okay, don't leave it this one. This one is also the part of solution or part of roots. So we write a d square plus a square. Okay, we write d square plus a square which is equal to 0. So we write this one at d square which is equal to minus a square. Okay, d square is equal to minus a square, and we know that whenever negative term come with the any square, they are a complex number which is present. Now entire numbers are a complex number, but iota whenever it is present, then we generally refer it as the complex number. Okay, so d square we write a negative 1. Okay, minus 1 into a square means minus a square. Okay, so that negative 1 I am writing minus 1 a square as it is here. So we know that iota square is a minus 1. Iota square, what is the value for iota square in a complex number, which is minus 1. Okay, so replace here d square which is equal to iota square a square. Okay, so this one is the value for d square is equal to iota square a square. So we write the its root as a d is equal to plus minus iota a. Okay, plus minus iota a. Now we can observe here we got the two roots. They are real. Okay, that means we don't have iota present here. They are the real, and we got the here one root which is the imaginary. Okay, that means the complex number which present here. So how can we write their solution? Now see that the solution. So we have to take the solution for this one as our roots are real and unequal, and this one as a complex number. So complementary function. So I'm writing the complementary function for these two one only. Okay, don't get confused. Don't write all solution together. Just write down the solution that you have. Okay, as a real or as you have complex. Okay, so we write c1 e to the power m1x. Okay, m1x means ax plus c2 e to the power m2x means minus ax. Okay, this one is a complementary function for these two roots. Okay, but what about for these ones? Again we have to apply a similar method for complex roots. Okay, so what we have complex solution for complex okay, which is a complementary function for complex numbers. So e to the power ax c1 cos bx plus c2 sin bx. Okay, now it is most challenging part here, how to find out the value for a and b. Most of the students they lost their marks here. Okay, now observe carefully how we have to find out the a and b, and how we can replace here. So we have the root d which is equal to, but we have the root d which is equal to plus minus I a. Okay, now we can see that plus minus I a. Okay, that means we write d which is equal to 0 plus minus I a. That means first number it is not there, means we write it as a 0. Okay, and this one look like a complex number. Okay, that means a plus minus I times b. A plus minus I times b, that means the value for a which is a 0 and the value for b which is a. Don't get confused. Value for b which is a here. Okay, and that value for a is a 0. So replace a and b in our complementary function. So we get the complementary function e raised to ax. Okay, what is the e raised to ax means e raised to 0x. Okay, under bracket c1 cos bx. c1 cos bx. B means ax. Okay, b replace b here. Okay, plus c2 sin bx means replace a here. Okay, this one is our complementary function for these two roots. Okay, now combine all of them, we will get the entire complementary function for our differential equation. Okay, so we write complementary function as c1 e to the power ax plus c2 e to the power minus ax. As we have constant c1 c2 it is here, so you need to replace this one as a c3 and this one as a c4. Don't keep all constant similar. Okay, all constant similar, that means it takes to the sum of the term which coming common between the term. Okay, so keep change this constant here. c4 I'm writing c4 cos ax. Okay, plus c5 sin x. c5 sin ax. Okay, and now see that e to the power 0x we write it as the one only. Okay, This one is our entire complementary function for our given differential equation. Okay, so this one is the entire solution that you all can refer for your preparation. Important example for your example. I hope you all have understood this example. Let's move for one more example. In our next example, we are going to consider a cubic equation that can be useful for synthetic division. Okay, so let's write our next example, example number 2. So I consider here d cube plus 3 times d square plus 3 times d plus 1, okay, which is equal to 0. So this one is a cubic equation I consider here. So I want the factors or roots for our linear differential equation. Okay, so don't get confused. Instead of that, you will get the question as d cube y by dx cube plus 3 times d square y by dx square plus 3 times dy by dx plus 1, which is equal to 0. And you will get to find out what you need to find, complementary function. Okay, you need to find out the complementary function. Okay, see that both are having similar meaning. Okay, this one is auxiliary equation and this one is our given third order differential equation. Okay, so we have to work for it's a complementary function. So as we can see that we have to apply one of the rule that I have given already. First rule, if alternate coefficient sum are equal, then we take it as the -1 as the one root. Okay, yes, and if sum of all coefficient goes to 0, then 1 as the one root. Okay, as we can see that alternate coefficient for alternate coefficient now we can say d cube has coefficient 1, okay, and its alternate coefficient is the plus 3, okay, which is equal to 3d square has a coefficient 3 and its alternate coefficient plus 1. We can see that 4, which is equal to 4. That means sum of alternate coefficient it is equal. So if alternate coefficient it goes to be equal, then we write d as a -1. Okay, d as a -1 is one of the root. Okay, is one of the root. D as a -1 is one of the root. Okay, now let's go for the finding remaining two roots using synthetic division. Okay, so apply synthetic division. How we can write the synthetic division? So we take this one as this format. Okay, -1 it is coming here. Okay, first root we are writing here. So remaining take the coefficient from our linear differential equation. First coefficient 1, 3, 3, 1. Okay, write down this one, 1, 3, 3, 1. Okay, these coefficients are here. So as we don't have anything here, take 1 as it is downside here. I'm taking that one here. So multiply both of them, -1 into 1. Multiply -1 into 1. So we get the -1. Add both of them, 3 minus 1, we get the 2. Again multiply both of them here, -1 into 2, -2. Add both of them here, 3 minus 2, which is 1. Multiply both of them here, -1 into 1, which is -1. Add both of them, we'll get the 0. Make sure that we want that one 0 always. Okay, yes, we got this one. Now convert it into the quadratic auxiliary equation. So we first it goes to the d square, second d to the power 1, and last d to the power 0, which is equal to 1. Okay, so our quadratic equation d square plus 2d plus 1, which is equal to 0. Okay, this one is our quadratic equation. Now what we do, we are going to find out the roots for this quadratic equation. So as you are going to find the roots, we write this one as minus, we want the multiplication of two number, which is a 1. Okay, -1 into -1 we write 1. Okay, and a -1 plus -1. So if you are going to add -1 plus -1, is it possible as a -2? Let me consider, check here, 3 minus 1. So we want the plus 1 here. Okay, so we write d -1 and d -1, d plus 1 and plus 1. Instead of -1, we take it as the plus 1. Okay, plus 1 multiplied by plus 1. So plus 1 into plus 1, 1, and plus 1 plus 1, we write it 2. Okay, so we write our auxiliary equation as d square plus d plus 1, which is equal to 0. I written 2d as a d plus d, as we have two separate factors here. Okay, take d common here, d plus 1 remaining under bracket here, plus d plus 1, take this one as it is here, 1 common between them, which is equal to 0. So d plus 1 and another d plus 1, which is equal to 0. Okay, so multiplication of two bracket 0, that means we write d as a -1 first root and d as a -1 second root. Okay, as earlier we have d as a -1. Okay, as we have earlier d as a -1, one of the root. Okay, so we have three roots as a d which is equal to -1. we can see all roots are repeated. Okay, all roots are repeated and equal. How the roots are? Roots are repeated and equal. How the roots are? Roots are repeated and equal. Then we write their solution y of x or complementary function. We write it's a complementary function. Roots are real and repeated. Then we write c1 plus c2x plus c3x square e to the power minus x. Okay, that means m1x, that means m1 I considered it as a minus 1. Okay, or you can write this one as c1x cube plus c2x plus c3 e raised to minus x. Okay, this one is your required complementary function. Okay, so now see that, guys, how easy solution it is. Okay, you will get such a question for 3 or 4 marks in your university SPPU question paper. Okay, so see, this one is the entire solution. I hope you all have understood this solution. Okay, so at the end I have some of the homework for you all. Okay, let me write here homework for you all. Here are the 2 example I consider here for your homework. Okay, these are important questions. Okay, so make sure that you have to find out the answer and comment this answer in my comment list. Okay, comment, I want in my comment that answer for these 2 questions. I hope you all have understood my today's entire lecture, which is completely based on complementary function. Okay, so how can we find out the complementary function? So I hope you all have understood and like my today's video. So if you understood it, let me know in my comment section. Okay, so similar video I'm going to upload into my next session also. So thank you everyone. Thank you for my today's lecture.